Okay guys, today the topic of our discussion is the fundamental theorem of arithmetic and its applications. As you know, fundamental theorem of arithmetic has many applications in mathematics, and so a vast syllabus is covered with this. But I will bound myself up to the 10th class only. So the limited applications uh, that are applicable up to the 10th level only. So for that, uh, first I will remind you some numbers which already you have been read in your previous classes. Like that, you can say the first is even number. What is even number? A number which has a factor 2. You can say that is even number, or you can say if it is divisible by 2. So a factor and divisibility means same. How can you say that? If 2 is factor of a number, then that number must be divisible by 2. This is a certain property. So be okay if I say it is a factor or it is divisible by that factor, means the same value. Okay, so if 2 is factor, or if 2 is divisible, if 2 is factor of a number, or that number is divisible by 2, you can say that is even number, and you can start it from 2. So as you know, even numbers are starting from 2, 4, 6, 8. All are multiply of 2. So multiple of 2, divisible by 2, or a factor 2 means same. Again, you can say odd number. What is odd number? A number which is not even, means 1 is not even, that is odd. 3, 5, 7 and so on. So we can take help of even number to define odd number. What is odd number? First, you can say odd number is that which is not even. Again, you can use property, a number which has not 2 as a factor, or you can say a number which is not divisible by 2, that is odd number. So odd numbers are starting from 1 and go on. Both are infinite, there is no finite even. Okay, the third one is prime number. What is prime number? A number which is not divisible by any number except itself. This is the definition. Means a number which is not divisible by any number other than 1 and itself. Means a number which is divisible by 1. As you know, every number is divisible by 1, so I take 1, and itself. And this is natural property that every number is divisible by itself. So except 1 and itself, there is no any other number which can divide the prime number. Okay, means you can take example. For example, 7. As you know, 7 is divisible by 1 and 7 is divisible by 7. But can you find any other number which can divide 7? No. Means 7 has only 2 dividers. 1 and 7 are only its divisors. Okay, so Prime numbers are starting from 2. Do you know 1 is not prime number? So keep remember, or I can say do remember that prime numbers are starting from 2, not 1. Be okay to that point. 2, 3, 5, 7, 11, 13, 17, 19, 23 and so on. So 1 is not prime. First point. 1 is not prime. Second, 2 is only even prime. This is the point. 1 is not prime, the first point. Second is 2 is only even number, which is prime number. Except 2, all primes are odd. This is third point. You can remember. Except 2, all prime are odd numbers. Okay, only 2 is the even prime. These are points which you have learned about already in your previous classes, so come to the point. Also, you have learned that if you have to find LCM or HCF of two numbers, then you have a process. You have learned about that, but I will give some reminders like that. If we have two numbers or AB are only two numbers, then you know what is HCF, highest common factor, HCF or GCD. GCD means greatest common divisor. Greatest common divisor. And what is HCF? Highest common factor. So both are same. And how do you find that? Make factors of AB and you can select few factors. How? Smallest power of each common prime factor means product of smallest power of each common factor. Each common factor. You can say each common factor. I will use the word prime factor. Okay, means we will find prime factors of AB and we will see what are the smallest power of prime factors and product them, you will get HCF. Again, if you have to find LCM, so the process of LCM is also in a short form. You can use as product of greatest power. Product of greatest power. of each prime factor of each prime factor. So in HCF we use smallest power, and in LCM we use greatest power. So this is not a big question, as you have learned about that. Also you can remember this, product of these two numbers is equal to product of LCM and HCF. So if you have find HCF, you can use this formula to find LCM. Also we have 4 variables, and if we have 3 variables, then we can find the 4th one with this formula one. Okay, so guys, we have left one point here, as this is prime, and the 4th one you can say the composite number. What is composite number? Very simple, which is not prime. Be okay. What is composite? Which is not prime. So 2 type of numbers only, prime and composite. Composite numbers can be identified as, you can say, which is not prime, but also you can find if factors like that. You can take example 6, which can be factored as 2 and 3. So every composite can be factored as prime, means every composite has prime factors. Very simple one. So all the above discussion is only for remainders, because you have learned about that in your previous classes. Now, what is uses of fundamental theorem of arithmetic? So first, what is fundamental theorem of arithmetic? Fundamental theorem of arithmetic. Fundamental theorem of arithmetic. What is this? We have just definition in this class, and so I am limit myself up to the definition only. What is definition? Every means each composite. What is composite? Which is not prime. Each composite number can be expressed as product of primes. Each composite number can be expressed as product of primes, and these prime number will be unique, means, and these primes will be unique, means that representation will be unique. Take example. As you know, 6 is composite and it can be factorized as 2 and 3. So what does fundamental theorem says? It says this composite can be written as product of primes, right? This 6 can be written as product of 2 and 3. These are primes. First. Second, these factors are unique. Can you find another way or another factors which can be said as prime and their product will be 6? No. So this is the property. What does property says? It says every composite can be written as product of prime factors, and these prime factors or this representation will be unique. Unique means there is no another way, there is no another prime factors this number can be represented by. Okay, this is the definition. So first point is that any composite can be factorized. Prime number cannot be factorized. As you know, if you take 7 cannot be factorized as the product of primes. 13, 17, 19. So you can take any number. If you say this 17 can be written as multiply of 17 and 1. But I have clearly told you that 1 is not prime. 1 is not prime. So if you write 17 as product of 17 and 1, that is not prime factors. So only composite numbers can be factorized. But if you think you have composite number 16 that can be factorized as multiplication of 2 and 8. 2 is prime factor, but 8 is not prime factor. 8 is composite number. So that representation may be many's, but the word prime factor makes this significant difference. So fundamental theorem clearly says that the composite number must be factorized as prime factor, not composite factor, as prime factor, and that process will take you on the result as unique representation. So if you take 6, I take 6, you can take another number, that is 24. So 24 can be factorized as 2, 3, 2, 2, right? You can write it as 2 power 3 into 3 power 1. So prime factors are 2 and 3 only. But if you take 6 and 4, that is also 24. But here 6 is not prime, 4 is not prime. Representation may be different. But if you take prime factors, then this representation will be unique. So be okay to this example. This is not unique. Try to understand, this is not unique because this is not prime factors. Prime factors are only these, and you have no another way, another prime numbers which can be represented as. Okay, so I think you have clearly understand this. But if you have any query or any problem or any doubt, you can share it with us in our comment box. So there must not be any doubt. All doubt must be cleared. Our motto is only to clear the concept, to clear all doubts. So concept does not contain any doubt. Clear concept does not contain any doubt. Be okay to that point, right? We will use prime number and its applications in the exercise because there is only 2 points here: find HCF LCMs and using of these fundamental theorems. How we can use to find LCM and HCF by using fundamental theorems, we have to come to the exercise 1.2. So exercise 1.2, this will clear our more points. So first question is very simple. Express each number as product of prime factors. We have given 140. This is the number. As you know, 140 can be factorized with the help of this process. We will get 70, 35, 5, 7. So this can be written as 2, 2, 5, 7. So 2 power 2, 5 and 7. All are prime factors. So you can remember that when you are making prime factors of a composite number, you can write it in any order. You can start it from 5, 7 or any 2, any number. But you should, I am using word should. You should try to take its ascending order, right? First smallest, again bigger and so this is standard form of this. You can say first 2, then 5, then 7. Okay. Another example you can take. This is not a very difficult one. I am taking third one, that is 3825, and again using the process 3825. As you know, it is not even and not divisible by 2. You can try for 3, and this 3 will be 1, 2, 7, 5. Again you see that it is divisible by 3, 4, 2, 5. 5 to 7 for 11, it will not divisible by 3, and you can take 5. 8 is 40 and 5, again 17. So this can be written as 3, 5 and 17. So fundamental theorem clearly says that every composite number can be written as product of prime factors in a unique way. In a unique way, this representation will be unique. Again, the question number 2, very easy. Find LCM and HCF of the following numbers. The first one is 26 and 91. 26, 91. First write 26 as product of prime factors, that is 2 and 13, and 91 as, that is 7 and 13. Now HCF, as I have told, you have to take smallest. What is smallest? Common factor. What is common factor in this? 2 is not common, 7 is not common, just 13 common. So smallest power of common factor, that is 1. Smallest power is 1, and that is 13 only. That is HCF. And LCM, what would be LCM? Larger one, or you can take greatest power, as I have told you about that. Here greatest power of 13 is 2. Okay, you can take 2, 7. So 2, 7 and 1 of the power 13. What would be that? That would be, I think, 192. Okay, again you can take the other way, the product of numbers, product of number divided by HCF, that is 13, and you can divide it as 7, that is 2, and 182. Oh sorry, this multiply will be 182. Okay, so you can use this method, product of number divided by 1 of LCM and HCF. So the question 2 has 3 parts, and I have done just one, and that is not a very difficult one, as you have done it in your class, previous classes. So also you have to verify. The question is verify. How to verify? As we know, the product of number is equal to product of LCM and HCF. So product is 26 and 91 and LCM is 182 and HCF is 13. Now multiply these numbers, you will get 26 1 ja 26, 2 2 3 4 and 2 2 3 6. Okay, and also you can multiply as 13 2 ja 26, 13 8 ja 104 and 2 106, 10 and 13 1 ja 13, add 10, you will get this. So verified. So this is not a big one. The application of fundamental theorem in this process is just as we have to take the product of prime factors of a number, nothing beyond that. Okay, now come to the question number 3, and you can choose part, only one part I will try to solve, that is second one. Nothing is different in this question. 3 numbers are given. As you see, 17, 23 and 29 all are primes, not composite, so cannot be factorized here. So cannot be factorized. Okay, factorized as primes. I again tell you, if you write 17 as 17 into 1, 1 is not prime. So this 17 cannot be written as 17 into 1 because of fundamental. Okay, so what is LCM? LCM will be just 17 multiply 23 and multiply 29, and number you will get 11339. This is LCM. So again here, what would be HCF? You can find HCF by that way, multiply of the numbers and divide by LCM, that is 11339, and you will get 1. So nothing is common because all are primes, and prime numbers have no common except 1. As you know, 1 is not prime, but the 1 is a number, so only 1 is common number in this. Okay, so come to the question number 4. Given that HCF of this, HCF of 306 and 657 equal to 9, and find LCM. What would be LCM? Very simple. Product of the number 306 and 657 and divide by HCF. As you know, it is given that HCF of these numbers, so we do not need to make prime factor of these numbers. Okay, so you have just to use the formula product of numbers divided by LCM, and you will get 22338. This will be the answer of this. Okay. Okay, now come to the question number 5. What is question number 5? As check whether 6 can end with the digit 0, means we have to find if 6 की n, where n is any natural number, can end with 0 for any can end with 0 for any n, means can we find this n so that the value of this number 6 power n ends with the digit 0. Now, as you know, if 6n end with the digit 0, if 6n ends with digit 0, then what would happen? It will be divisible by 5, because any number ends with 0 is always divisible by 5. Clear? So if I said if this ends with 0, then it will be divisible by 5, and I have already told you that if a number is divisible by a number, then that number must be factor of that. So 5 must be factor of 6n, right? If it divides this number, then it must be factor of this. And also so now we have to see if this number has a factor 5 or not. Also, 6 power n can be written as 2 power n into 3 power n. And in this process, 2 and 3 are only primes. Here 2 and 3 are only primes, not 5. In this representation, 5 is not a factor of this number, and by fundamental theorem, application of fundamental theorem, this representation is unique. This representation is unique. So there is no other representation. If you say any presentation may contain 5, but not possible, because fundamental theorem of arithmetic clearly say that any composite number can be represented as product of prime factors only. 5 is prime, you know, and the factor of this number is just 2 and 3, not 5. So how can you say that 5 divides this number? Means, so this number 5 cannot divide this number. So 6n cannot ends with 0. No chance. Why? Because if it ends with 0, it will be divisible by 5, and as we see, the composite number, this composite number cannot contain 5 as the prime factor of this representation, so 5 cannot divide this number, and so it cannot ends with the digit 0. So I think clear. Now come to the question number 6. Again I say, if you have any doubt, you can write in our comment box, and I will be pleased to give answer to all your queries as soon as possible. Also subscribe our channel so that we get inspiration from your side, and also click on like icons and bell icons I say, and like our video so that we can put more and more videos with better ways. So come to the question number 6. Explain why are composite numbers. Means we have to show that this number is composite. How do you show? Very easy. This is product and this is 1. You can take common 13. You will get 7 and 11. And here 1. You will get this number 77 plus 1 and 13 into 78. So is composite. Why? Because these are product of two factors other than 1. So it is a composite, not a prime. Again you have a question also. 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. And you can take common 5 and you will get 7, 6, 4, 3 and 2 plus 1. And this is 5, and multiply of these numbers. 2 3s are 6, 4s are 24, 6 are 144, multiply 7. 144 multiply 7. So this is also product of more factors, so composite, not prime. Very easy question. Question number 7. Question number 7. There is circular path around a sport field and Sonia takes 18 minutes to drive one round of the field, which Ravi takes 12 minutes for the same. Sonia takes 18 minutes, okay, and the other one Ravi takes only 12 minutes to take rounds. Suppose they both start at same points and at the same time and go in the same direction. After how many minutes will they meet again? How many minutes? After how many minutes? We have to find when they meet again, right? So this type of questions you have take experience of these questions in your 6th to 7th class also. We have just to find LCM of these numbers, and we have to find LCM. And I think you have remembered that a lot of question of ringing bells in 6th and 7th standards are given. If you remember that, this 18 can be written as 2 multiply 3 power 2. Okay, this is presentation, product of prime factors. Also 12 can be written as 2, 2 and 3. And as you know, you can find LCM directly. How? This is 2, this is 2, and highest power of this 2 is 2 power 2. So we will take 2 power 2, not 1. Again, this is common factor 3 and the power is 2, so greatest is 3 power 2, and you will get 4. This is 36, and after 36 minutes they will meet again. After 36 minutes they will meet. Okay, very easy exercise. So we have learned about application of fundamental theorems, first point, and second, what is fundamental theorems, as I have explained. But if you have any query about that or any doubt, you can put your query in our comment box. Okay, thanks.